The sarcomere is a subunit of the muscle cell which is utilized in contraction. It is divided by two Z lines and an M line. On the Z line, actin filaments extend.
They consist of an actin protein base with tropomyosin and troponin proteins.
On the M line and slightly overlapping the actin filaments, the myosin filaments extend and consist of a tail and a head.
Close to the sacrolemma, which is the membrane surrounding the myelin fiber, is a motor neuron. It will act to stimulate the contraction. Potential travels down the motor neuron, which causes the release of acetylcholine into the neuromuscular junction by exocytosis.
This triggers sodium channels to open, allowing for the influx of the sodium ion into the cell and enabling the depolarization of the cell. This change is detected, which causes the sarcoplasmic reticulum to release calcium ions into the cell. The calcium ions bind to the protein troponin, which causes tropomyosin to change shape and open the myosin binding sites on the actin.
ATP binds to the myosin head and splits into an ADP and phosphate.
The myosin head attaches to the actin on the binding site. The phosphate is released, and energy from the split ATP allows the myosin head to move the actin filament along its length. ADP is released, and ATP reattaches to the myosin head, allowing it to move back to its original conformation. This is the contraction of the sarcomere.
Rigor mortis. When a person dies, the membrane of the muscle cells become increasingly permeable to calcium ions. This causes the tropomyosin to change conformation and for the myosin heads to bind to the actin filaments.
After pulling on the actin, the myosin heads prove to be locked into this conformation, not having the ATP needed to detach from actin and allow the muscles to go back to a resting state. This causes the continuous contraction of the muscles.